Friends, my name is Anil Kumar Singh. In this video, I will explain about structural modeling. For explaining the structural modeling, I will take the example of multiplexer. Okay. So, what is multiplexer? Multiplexer basically 4 to 1 marks, 2 to 1 marks, 8 to 1 marks, like this. So basically multiplexer, what it will do, there is a select line, control line, C0, C1. This one is 4 to 1 marks. In this 4 to 1 marks, x0, x1, x2, x3 are the inputs and M as an output, and C0, C1 is the control line, select line, to select one of the input. All these inputs are multiplexed through the output of the mux, that is M. Okay, at a time, one input will go to M output. Okay, so which input will multiplex, that will be depend on control line, it means select line. So this is the multiplexer truth table. C0, C1, these are the control line and M is the output of the multiplexer. Okay, when C0, C1 are 0, 0, x0 will be selected and multiplexed. Okay, so M equal to x0. X0 is multiplexed. Okay, so if C0 1, C1 is 0, x1 will be output, that is M equal to x1. If C0 is 0, C1 is 1, x2 will be multiplexed, that is M equal to x2. Similarly, C0 is 1, C1 is 1, x3 will be multiplexed. It means M equal to x3. This is basically 4 to 1 multiplexer. Okay, this is one implementation of 4 to 1 mux. We can also implement this functionality using 2 to 1 mux only. So how to design 4 to 1 mux using 2 to 1 mux? See, this is the design where we are using, basically here 8 to 1 mux implemented. Okay, so this one is 4 to 1 mux. So how to implement 8 to 1 mux using 4 to 1 mux? Okay, see, here 4 to 1 mux already I have explained here. Its functionality I have already shown here in the truth table. See how to implement 8 to 1 mux. So this 4 to 1 mux having 4 input, this 4 to 1 mux having 4 input. So total 8 input, and this 2 output is going to 2 to 1 mux. Okay, so one of the multiplexer 4 to 1 mux output will be multiplexed by 2 to 1 mux, and that will be assigned to y variable. Okay, so in total, if you see like this, at inputs, in input side there are 8 input and output side there is 1 output. So this is basically 8 to 1 mux. I am not using directly 8 to 1 mux, I am designing 8 to 1 mux by 4 to 1 mux. This is the concept of structural modeling. We are changing the structure of the multiplexer. Okay, so what is the truth table of this 8 to 1 mux by implementing 4 to 1 mux and 2 to 1 mux? So this is the truth table. See, S0, S1, S2, there are 3 control line, it means select line. So S0 is the LSB, S1 followed by S2. Okay, S2 is here, see here. So S2, in S2 column there are 4 0, then followed by 4 1. Okay, so S2 is fixed to 0. It means I0 will be selected. Every time I0 will assign to Y. Okay, up to this line. So S2 is 0, I0 is selected, and S0, S1, 0 0. If both input is 0 0, output will be I0. This I0 will be bypassed through the 2 to 1 mux to output Y. So here I0, Y equal to I0. In this case, this multiplexer is not enabled because of S2 is 0, I0 is selected, not I1 is selected. Similarly, if S1 is 0, S0 is 1, 0, 1, I1 will be selected and bypassed through 2 to 1 mux and assigned to Y. So Y equal to I1. Similarly, if S1 is 1, S0 is 0, I2 will be selected and bypassed through the 2 to 1 mux and assigned to Y. Similarly, if S1 is 1, S0 is 1, I3 will be assigned to Y, I3. Now see, S2 is changed from 0 to 1. It means I0 is not connected, I1 is connected this time. Okay, so S2 is 1, S0, S1 is 0 0. It means these two input are 0 0 and S2 is 1. It means this one is selected, and 0 0 means I4, first one. I4 will be bypassed through the 2 to 1 mux and assigned to Y. See. Similarly, if S1 is 0, S0 is 1, I5 will be assigned to Y. Similarly, S1 is 1, S0 is 0, I6 will be assigned to Y. S1 is 1, S0 is 1, S2 already 1, so I7 will be assigned to Y. In this way, we can multiplex all the 8 inputs one by one to the output Y by proper selection of the select variable. Okay. In this way, we can model the 8 to 1 mux using 4 to 1 mux. Similarly, we can model 4 to 1 mux using 2 to 1 mux in similar approach. Okay. In next video, I will explain how to design 4 to 1 mux using 2 to 1 mux, and also I will simulate and implement in the Xylene Vivado tool, and I will verify all this truth table functionality by simulating the design. Okay, so please please watch the next video so that you can verify all this functionality. Thank you so much.